So hi guys, welcome to my channel. Today we are going to provide you with the editorial of Codechef Long Challenge July 2020 problem ADAKING. So let us look at the problem statement. So I have given the problem in the description also, so you can check the description and clear the problem from there also. And I'll provide you a summary of what the problem is. So basically what we have been given is, we have been given an 8x8 chessboard with 64 cells, and we need to place a king such that it can move exactly k number of cells, k distinct cell it can occupy. So how we can do this is, we are provided with the obstacles, so we need to place obstacles around the king such that the king can move exactly k number of cells, right? K number of distinct cells. So in the case if you don't know how a king moves is, a king can move one step at a time in all possible 8 directions. So we need to find a configuration in which we'll place some obstacles, a king, and the king can only move up to k distinct number of cells. So let us clear this problem with the help of examples. Suppose we are provided with these examples, right? So these are the test cases and these are the values of k. So in the first case, the king can move only to one distinct cell. So this is the possible configuration. There can be many configurations, but this is one of the possible configuration in which we place the king. King is represented by O and obstacles are represented by X. So we place the king over this position, and only this position the king can sustain. There is no other position in which king can move. So only one position. So this is the possible configuration for k equals to 1. For k equals to 5, let us examine this possible case. So for k equals to 5, the one position in which the king is already occupying a cell, that is one position, that will count to one position, and the king can move two other positions in its right and one position in its upwards and then move right. So in all it can move up to 5 positions. So this is one of the possible configuration for k equals to 5. Similarly for k equals to 9, we can also see that king can move here, 3 positions here, and 3 position downwards and 1 position here. So in all it can have 9 positions. And for k equals to 64, it can travel up to any cell because there are no distinct boundations for it. There are no the possible x is not there in any of the 64 cells. So there are no possible boundations. King can move up to any cell, any possible 64 cells. So we need to find a configuration in which we can limit the movement of king up to k places, k distinct cells. So how we can form the approach of this problem, let us see. Yeah, so basically if we have k equals to 4, so what we will do, we'll first make the whole 64 8x8 board filled with obstacles, right? So we'll fill all the cells of the board with obstacles and place the king at the first cell 0, 0. So we'll place the king here. And now what we'll do, we'll reduce the size of k. Why? Because we have occupied one cell in which the king is there. So what we will do, we'll reduce the value of k. Now k equals to 3. From k equals to 4, k equals to 3 because we have placed king at cell 0, 0. Now instead of traveling in multiple direction, what we can do, we can make the king travel horizontally, right? How we can do this is, we'll make it a dot here. We'll remove one obstacle from here so that the king can move here. Similarly, we'll make one more obstacle removed, and similarly one more. So when we will stop, when the value of k is equals to 0. That means we'll stop when we know that all the values of k have been used and the king can move exactly up to k distinct cell. So how king can move in this particular configuration is like this. And there is no possible way that the king can move to any other cells. So there are no boundations on the obstacle that we need to reduce the minimum number of obstacles. We can use any number of obstacles, but what we need to do, what we need to take care of is the value of k, so that the king can move exactly up to k distinct cell. So I hope the solution is clear from this particular example and animation. So let us look at the coding part of this video. Okay, so now let us see the coding part of this video. So it is quite simple, as asked in the problem. We'll do the same. So we'll get the input of k and we'll make a board of 8x8. So first of all, as we have discussed in the approach, we'll fill all the cells with the obstacles, right? So we have been taking 2 for loops and we'll fill all the cells of array I, j with obstacles. Now the second step is, we need to place the king. So what we will do, as discussed in the approach, we'll place the king at 0, 0, cell 0, 0 with the character O. So the king is represented by the character O, and we'll reduce the size of k because we have occupied one cell. Now in the later part of the code, what we will do, we'll put 2 for loops, and what we need to do, we need to remove the obstacles for exactly k number of times horizontally. So first if condition is if I equals to 0 and j equals to 0, we'll simply continue. Why? Because we have placed king at 0, 0. So we have already taken the cell. So we need not to reduce the size of k or place a dot over there, because we have already taken that cell for the king. So if I equals to 0 and j equals to 0, we'll simply continue. Now if k equals to 0, we'll break down from the loop. Why? Because all the obstacles have been removed till k times, right? So we need to find exactly k number of times. So if k equals to 0, that means we have occupied exactly k cells, right, for the king. So we'll break down from the loop. And else, if these two conditions are not fulfilled, then what we will do, we'll replace the obstacle with dot and reduce the size of the k, as discussed in the approach. And now after this for loop, what we'll do, we'll write one more if condition. If k equals to 0, then break. Why? Because if this condition hold true, then the control will also break down from the outer loop as well, right? So we'll write this if condition there also. And at last, what we need to do, we need to print the configuration. So for I equals to 0 till I less than 8, j equals to 0 till j less than 8, and 2 for loops, what we'll do, we'll print the whole configuration of the chessboard. So this was the approach of this problem. So if you want to learn dynamic programming, so I have made a 15 days dynamic programming tutorial in which you will learn the different concepts of dynamic programming, like states in dynamic programming, memoization, how we can apply that in particular problems for competitive programming. So you can have a look at dynamic programming series. And if you want to learn graphs for competitive programming, I have also made a series for graphs also. So you can also learn graphs for competitive programming. The link to these two series is in the description, so you can have a look at it. And at last, please do like, share and subscribe my channel. Thank you for watching.